with that being said, there is a reception tonight after this is over, if you're staying tonight, so I'll find out exactly where the reception is, and we'll go ahead and get started. Juan Carlos is going to start off the first part of this session. We're going to have a soil health talk.
Not a whole lot of people, but hopefully we can have a nice discussion. And we're not going to have kind of like the lecture type presentations that we have been having the whole conference. I mean, we're going to have some presentations, but they're going to be shorter than normal. And so the way it's going to work is after each presentation, there will be some time for specific questions of that specific study. But then later, once we finish these presentations, we all sit here in front of you, and we can talk about, discuss and suggest and have more general questions, not so specific of that study. What we have been working on, and that's the reason of this roundtable discussion, over the last 4 years at Clemson University, we have been working on soil health studies. We have seen how there is nothing for this part of the country. There are some, on this topic, there are some work done on the West Coast and in the North Atlantic on apples, but there is nothing on peach and nothing for this region. And so we started with different soil amendments, not knowing what we were gonna, not knowing what to expect, thinking like everything that you do with soil takes a lot of time, and really not expecting much for the first 2 or 3 years. But it has been quite a journey and quite surprising because we have seen some very interesting results, in some cases starting even from the first year. So as you're going to see, there are different soil amendments we're using. We have some works on using mulch, composted mulch. We have food waste compost. And again, it's all the work from the last 4 years. Now we are starting a new phase. This winter there will be 2 farms in South Carolina, 3 farms, sorry, in South Carolina, that will be starting some on-farm trials, and at the same time at Master Farm we will be carrying out another experiment, kind of like from what we have learned in these studies. So with no further ado, I'm going to present the first presenter, who is Jeff Hopkins, and he's going to talk about this his study at Master Farm.
You got it. Where's my button? Or should I just use the?
Either one. Is there a point?
Okay. Good afternoon. Good afternoon. Good afternoon. Hey, everybody. So I think I know everybody in the room, but if not, Jeff Hopkins is my name. And what I do for a living is I manage Clemson University's Musser Fruit Research Center. And so that's my day job. And my night job is decided a few years ago to go back and get my master's degree. And
put the microphone closer.
Can you hear me?
A little closer.
That's as close as I can get it without bending down. So, hey, Walker. Jeff Hopkins is my name. So a few years ago, I decided to go back and get my master's degree. So I'm going to give you a quick run through, 15 minutes of what we've looked at and what we're learning from one of the original studies in the soil health. Is that good? Okay. Okay, so a few years ago, this is how a lot of the good things in my life come around, is I was drinking beer with Guido in Germany. A lot of good ideas usually come from that. And we were there for a fungicide resistance conference, and while we were there, we went to a German research station, much like the Musser Farm, and we talked with the station director there, and you can see in the middle, right here in that middle row, they planted cherries, and it was a cherry field and a research station in Germany. And we were asking them about if they had bacterial canker issues in cherries, which we all should know that have terrible problems with bacterial canker, at least in our country. So her response was definitive, no, they don't have bacterial canker issues because they have good soil. I think that was the right, I understood it correctly, even though it was said in German, but that was the idea, is there was no bacterial canker in the just cherry replant site in Germany because their soil was very different than ours. We have warm winters. We have a lot of organic decomposition that happens there. They freeze hard in the wintertime, and so they have high organic soils, and we don't. But regardless, they didn't have any canker problems in their cherries, and we thought, well, what if we tried that? What if can we replicate those healthy soils that we saw that didn't have any canker problems to improve the peach production in South Carolina? So we decided, this is all over a nice German pint here. Can we do it? What could we do? And so we're going to put in a peach orchard with sort of the gold standard soil health treatments and see what happens. And we'll go into what that looks like here in just a minute. And then to answer the questions, do improved soils equal resilient peach trees, trees that are resistant to disease, to the problems that we have here in South Carolina or in Georgia? And if that does work, then how do you quantify? How do you quantify, is it a healthy soil? Is it a healthy tree? And is there any value to it? Is it any fiscal advantage? So that was the idea. And then the orchard that we put in, see if I can get the pointer to work here. Well, anyway, you see the white box down there. So that we'll go into the details of that, but that's at the Musser Farm. That's the soil health study that we put in. Okay, so South Carolina, what are some of our soil problems? Our poor orchard soils lead to production problems. We have erosion, compaction, crusting, low base saturation, and then out of balance soil cations. So that would be magnesium, potassium, calcium, low organic matter, and low soil pH. So, and then the last one would be the nematodes. So the soil problems then lead to tree problems. So your soil problems lead to weaker trees, allowing pathogens to flourish and reduce annual productivity. And the idea is hopefully we can expand the total lifespan of the trees. So even though there's more input up front, if we have healthy soils, perhaps we can make it beyond 13 years. Maybe we can make it 15 before we're pulling orchards. So here's the experiment. Can we improve peach tree health by improving orchard soils with mulch amendments? The mulch that we used was a free mulch that we got from the Oconee County landfill. They had a big tropical storm came through a few years ago and knocked a bunch of trees down, so ground them all up, hauled it to the Musser Farm, and then let it rot for a few years. So it was this nice, you'll see a picture in a little bit actually, a nice black organic compost, or we're calling it single ground composted mulch, municipal mulch. And so then we took a new orchard, planted a new orchard on a replant site with different soil mulch amendments, and we'll talk about that in a minute. And then the idea is to use multidisciplinary measurements to improve or to quantify the soil improvements. So how do you count it? And then the tree health will be, does improved soil health improve the resilience of the trees? And the way we quantify that is through rating for pathogens, rating for bacterial canker. So the methods that we used, so we installed the orchard and then analyzed the soil, measured the trees, and then we're just getting into the pathogen side of it. So then we'll be rating for pathogen resistance to Pseudomonas syringae or bacterial canker. Okay, so remember the numbers. Here's our one. How do we set it up? And so we have, let's see, does this work over there? No, I can't do that. Okay, so we installed a new orchard with a different soil mulch treatments. So the C is control. That means there's nothing. That was just the original soil. And then the 1X that we put in was 6 inches of pre-plant compost, and then an annual application of 2 inches of compost. And then the 2X would have been, I don't know if any of y'all know me, but if some is good, more's got to be better, right? So that's that was in keeping with my personality. So we put in a 2X, which is like nobody's ever going to lay down 12 inches of compost in a peach orchard. That's just ridiculous. But we did it anyway, and we had copious amounts of compost to use. So that was that. And then we planted ruby prints, July prints, and big red, 5 per row in each row, randomized. Okay, so we tried a lot of different methods. The first picture is we're using a backhoe to dump the mulch out. We had tried several different ways to like calibrate it and do a nice job of putting out a nice clean 6 or 12 inches of mulch, but it turned out just to do it the dirty way was just dump it out of the tractor bucket and back drag it because there's so much material, so much volume that had to go down. So we did that, and then on the far right, you can see that we use a subsoiler to back and forth to get that worked in, and then we disked it as well, disc haired it. And then the center picture, you can see that red line near the top on the measuring stick, that's 16 inches, and the bottom that's how deep we were able to get the material worked down before we bedded, was 16 inches. So we felt pretty good about that. It worked the material down nice and deep into the soil. And then next thing we did is we bedded it. I'm pretty sure all y'all have seen this bedding plow at this point. It's the same bedding plow that we've always used. So we pulled beds and put the material up on beds. And then this is what it looked like right when we planted it. So you can see on the far left, you can see that's the control row. There's no soil treatments at all. That's just what our soil looks like. The next row to the right, the middle row there, that's the 1X treatment, and the row on the right is a 2X treatment. So that was 6 inches and then 12 inches of pre-plant material. Then we planted, and then we topped it up with fresh mulch. The one thing I wanted to show you on the next video is the mulcher that we use. It's called a row mulcher, and I'll show you a quick video of what that looks like if I can make it play. So it's not anything complicated. You fill the hopper and you dump it out. Brand is Mill Creek, is what we landed on, Mill Creek Row Mulcher. Was that loud enough for y'all to wake you up? One more, keep going. Okay, so the results, I thought this was kind of funny. Right after we put the mulch out, I got kind of tickled by the signs. So this is row 7, row 8, and row 9. So this would be controls row 7, the 2 inches is row 8, and the 4 inches is row 9. So I thought it was kind of, the signs told the whole story there of how thick the mulch was we laid down. So you can see row 7, no mulch, about 2 inches on row 8, and that's the annual application. So 6 inches pre-plant, 2 inches annually on the 1X, 12 inches pre-plant, 4 inches annually on the 2X. Okay, so I'm going to give you 3 highlights of results. These aren't near the total results that we got. This is just sort of the 3 highlights that came. I want to tell you a little bit about the soil, the trees, and then yield as we've seen it over these last 3 years. So the cation exchange capacity, everybody remembers back from soil class? Anybody not know? So a cation exchange capacity, go ahead and claim it. Claim it if you don't remember it. No hands? All right. So cation exchange capacity is the exchangeable, the cation. So you have the main ones we're interested in, magnesium, potassium, and calcium. So those are the ones that we're mostly interested in. And even though you can put those things down if you don't have exchange sites, that's the exchange sites are where the soil and the plant interconnect, right? So you have it and you have exchange sites, the plants can use it. So so the reason I chose this particular slide is it kind of told the broad picture of what we're looking at on the soil changes. So you can see on 2020, this was right as we were planting. Just by putting down the mulch, we doubled essentially our cation exchange capacity. And that trend held true until 2022, we've almost tripled it. And so on a Ultisol soil, our standard is usually about 5 milliequivalents per 100 grams. That's pretty standard. It could be even lower than that if you have particular sandy soil. But we went from 5 to 10 to almost 15 now. So we're exchanging lots of cations. So that's good because it means that not only do we have more calcium, magnesium, potassium in the soil, but we're also able to use them. So that's a pretty interesting result to me. So let's go one more. So this would be the trees as we start looking at the trees. So one measurement that we like to use that sort of tells a broad picture story, just like the cation exchange capacity of the soil, the trunk cross-sectional area about yay high off the ground. We measure the diameter and turn that into a cross-sectional area. So that there's a tight correlation between the size of the tree, the production potential of the tree, and the trunk cross-sectional area. So the bigger trunk cross-sectional area, the more potential you have for growing or for harvesting fruit. And so you can see the mulch amendments increased the trunk cross-sectional area in general. So you've got, again, on the left, the color codes are the same, so would be the controls, and then the next two on the right, the 1X and the 2X, the trees are bigger. Healthy soils, better soils, bigger trees. I'm going to go back one, actually. So I did want to say on the 1X versus the 2X on the cation exchange capacity, there was more cation exchange capacity from 6 inches to 12 inches, but I'm really doubting that there's any great advantage. There's a point of diminishing return that I think we've reached between 6 inches and 12 inches of amendments. So I did want to make that point there. Okay, so this is the yield. This is what ultimately what pays the money here. So it's not exactly as I'd hoped it to be, but the yield of amended soils it currently is comparable with control, and with a caveat is that we found that the organic nitrogen is kind of tricky. So even though there's essentially it's the same yield from control to the treatment rows, what we found is that we had a delay in bloom from I think it was cooler soil temperatures delayed our bloom by a few days, and then when we went through and thinned, we didn't go back through and thinned a second time, and so we ended up with some yield on those later blooming trees that we ended up having to drop because it never sized and we couldn't measure it in the results. So I just want to say the organic nitrogen component is a trickier component than inorganic nitrogen. When you buy a bag of 10-10-10, you know exactly what's in there. You put it down and you can calibrate easily. But when you're putting down organic nitrogen amendments, it's more complicated. And so the next step will be in the next few months, we're going to start rating for bacterial canker. And so we have some short-term ratings that we'll be looking at. Winter ratings we'll be doing here shortly for summer pruning, canker strikes on summer pruning stubs. And then we'll, in the spring, we'll rate for the winter pruning that we do here shortly. That's the short-term rating. And the long-term rating, we'll be looking at tree survival and the tree decline ratings. And the hope is that the trees are going to last longer if they're in better soils. And then in conclusions, it's not a perfect answer. The amending the soil is doesn't solve all the problems, but we can significantly improve orchard soil health parameters with these mulch additions. And the trees with the improved soils grew larger and maintained productivity, but my hope is that this next year, knowing what we know now, is that we're actually going to do a lot better on yield because we'll be able to get in and we'll actually pay more attention to our thinning to make sure that was done well. And I think this year will show that there's more yield on the controlled on the treated trees, but have to be real careful and sort out the nitrogen component because balancing orchard nitrogen with organic additions it's a little trickier than inorganic nitrogen. And with that, there is more to the story, and part of what's particularly interesting, Dr. Canal is going to tell us about with nematodes here right now. So thank you.
Jeff, did y'all do any fruit quality assessment to see if there's a difference?
We did a little bit, and we'll be doing that. Most likely, we're going to start pulling that in this year. On year 3, we ran out of margin to do stuff, but I think that's part of
That red button?
Okay.
That's the pointer.
Okay.
And forward.
Advance
backwards.
us.
Yeah.
Okay.
If you hit that, the screen will go black.
Hopefully I'll not hit that.
Specifically around occurrence or lack of occurrence of bronzing. Occurrence or lack of occurrence of bronzing. Well, since last year, I think there was some discussion around the potential lack of nutrient exchange.
Yeah, and he'll actually be presenting that here in a few minutes. So that's on there. So the bronzing part of it. And that's part of it. If we can do better, if we can have more exchange sites, have a healthier soil, for our potassium, for our magnesium, for our calcium, does it balance itself out and end up with a better finish on peaches? So Dr. Melgar will tell us about that.
Thanks for doing my job.
What's that?
I said, thanks for doing my job.
Okay. Good afternoon again, everyone. Thanks, Jeff, for the great presentation. So Jeff did a very good job on introducing our project with the soil health. So I'll not talk about any of the methodology. I will quickly jump into my part. Just so you all know, I'm a Clemson nematologist. I joined Clemson in 2020, and that was the year this project was started, soil health project. So you can see on the picture, those tiny critters, those worm-like structures, they are feeding on the wallet. That's what we nematologists say. Nematodes do not feed on the plant, but they actually feed on our wallet. Okay, that's our slogan. So if you look here, these tiny needle-like structures in the head of the nematodes, they are called stylets. So these nematodes use their stylet to puncture the host cell. Most of the nematodes feed on the root, so they are root-feeding organisms. So they puncture the host cell, suck up the nutrient, and then cause damage to the plant. A lot of time, we don't even hear a lot of stories about nematodes, but believe me, they are very important. Okay, so typically we don't see the damage of the nematode in our peach orchards. To be able to see the damage, it probably takes like multiple years. Nematodes have to grow to a certain population level before they can introduce any damage symptoms. So I would say if the orchard is new and nematode population in the soil is very low in the beginning, we would probably start seeing the effect in like 3 or 4 years after planting. Okay? And that is the time when we start expecting the growth from the tree, especially for the peaches. So when the population of nematodes starts going higher, then we see some obvious symptoms like one on the left, the dieback symptom. And I think Greg mentioned briefly in the morning session about ring nematode. Ring nematode works with the Pseudomonas bacteria, and that induces peach tree short life. This is the tree with high level of ring nematode, and that suffered from peach tree short life. And these are relatively healthier ones. And there are a lot of different types of nematodes that attack peaches, not only the ring nematode. Some root feeding, we say root knot nematodes, they induce galls on the roots. And depending on the population density, if the number is very high, when we pull the root, we can clearly see these galls. And these are the egg masses of the root knot. I'll not go much deep into the biology of nematode, but just want to emphasize that there are a lot of nematodes that feed on our peaches. And few important things to add. A lot of times, although there are some nematodes in the field feeding on the plant, since we don't see obvious damage symptoms in the very beginning of the tree life, the damage caused by nematodes usually goes unnoticed. Some other that's partly because the symptoms expressed by nematodes can be very similar to other factors like the wilting. When we see some wilting, we obviously thought that's the water stress. If we see dieback, we might think of some bacterial or fungal infections. So a lot of times the damage by nematode go unnoticed. And the other important thing is that since nematodes feed on the plant roots, while feeding they cause wounds on the root surface, and those openings, those wounds create avenue for other pathogens to enter. So the indirect loss can happen from by allowing other pathogens to enter the host. The plant parasitic nematode, we say the bad nematodes that feed on peaches. There are 3 main nematodes. There are other nematodes too, but 3 are the ring nematodes, this guy, the root knot nematode, and dagger nematodes. These 3 nematodes are very damaging to peaches. We do have these nematodes in South Carolina peach orchards. Not necessarily to the very high level. I have conducted some survey in the upstate, but a lot of orchards have these nematodes. Some, like ring nematodes, some orchards have like very high number of those nematodes compared to others. And there is one new nematode, relatively new, called peach root knot nematode that specifically goes to peach. And our guardian rootstock is susceptible to that root knot nematode. The good news is that it's not widespread in South Carolina. It has been reported from 1 orchard so far, and I'm doing survey. Let's hope I'll not find any more sites with the peach root knot nematode. And this is the table just to give you an idea of how damaging the nematodes can be. For example, presence of 20 ring nematodes per 100 cubic centimeter of soil can trigger some management actions. So when we get samples and extract the soil and count the nematode, if we see any number above 20 for the ring nematode, we suggest for the some management actions. Could be cultural, could be chemical, depends on the number. Okay. And so I talked about the bad nematode, plant parasitic nematodes, but there is other group that is not very well studied. That's called free-living nematode communities, and there are different types of free-living. Some feed on fungi present in the soil, some feed on bacteria, and some feed on other organisms, including nematodes. And these nematodes, we say beneficial nematode because they tend to play a good role in maintaining the healthy soil. They balance the ecosystem in the soil. They feed on the antagonistic microorganisms like fungi and bacteria. And they help release the nutrients to the plant available form. So they have very good, good role in maintaining healthy soil. And a lot of time, ecologists use these nematodes, the free-living nematodes, as indicator of the healthy or unpolluted soil. Okay. So as a nematologist, my goal was to see the change in the population dynamic or the effect of moths on these 2 groups of nematodes. So with the test that Jeff just explained, we pulled samples twice a year in 2021 and 2022. The top 2 bar graphs are for the April 2021 sample. The one on the left has number of free-living nematodes per 100 centimeter cube of soil for each 1x, 2x, and control the mulch rates. And on the right is the plant parasitic nematodes. And it was very obvious to see that the beneficial nematode or the free-living nematodes were actually increased when we applied mulch, 1x and 2x, compared to the control, which did not receive any mulch. And exactly opposite, but in a good way for us, for the free-living nematodes, the one on the right, the ones that received mulch, 1x and 2x, had significantly lower number of those nematodes compared to the control. Okay. And same trend goes in July, for July sampling. So this is 1x, this is 2x, and control for the free-living nematode. The 1x and the control, they have statistically similar number, but 2x application had like significantly higher number of free-living nematodes. That's the good news. And the plant parasitic nematode follows the same trend as in April. The The ones that received mulch had very low number of those nematode, plant parasitic nematodes compared to the control. And I do want to emphasize that nematode population is affected by the season. So when the soil temperature goes down, their population goes down as well. We did the similar process in 2022. We sampled twice, but we sampled first in March, and second sampling was conducted in September. And the results were pretty much similar to that we obtained in 2021. The mulch application either significantly or at least numerically improved the number of free-living nematodes, as we can see in this one and this slide. And the mulch application suppressed the bad nematodes, plant parasitic nematodes. And we are still conducting this research. In 2023, we'll probably pull more than 2 samples just to see how the mulch application affects both nematode communities. The overall conclusion from the nematology part, mulch application does seem to improve the abundance of free-living nematodes in the soil while suppressing the plant parasitic nematodes at the same time. The impact of like twice rate of mulch application was mostly the better compared to the 1x application. From nematology perspective, the mulch application seems to improve the soil health, which is obviously determined by the number of free-living and plant parasitic nematodes. And to derive a conclusion that mulch application actually improved the soil health, we need to do further studies. And hopefully in next few years, we'll start getting like more data so we can build more confidence on the effect of mulch on those nematode communities. Okay, that's all I have on nematology part. If you have any questions, we would be happy to take those.
Anybody have any questions?
So this is both of us did it on the same block of trees. So the next one Dr. Melgar will be talking about will be a different orchard, different study, similar but different block. But if anyone has any questions about this particular study, it's supposed to be a little more round table.
Like in both years, your samples amount up in the fall. What was your thinking for the spring? You know, normal sampling should take place in the fall, right? So why were you doing the spring? What was the understanding for doing the two separate?
Okay, that's a very good question. So when we sample, it depends on what is the purpose of sampling. Like if we want to sample early in the season, that helps us determine if the population of nematode can be damaging by the end of the season. Okay. As a nematologist, if you are establishing a new orchard, I would definitely recommend sampling earlier so we can determine the number that can, like the maybe highest possible number that can go later in the crop growing season. But if your goal is just to know how much your orchard has, like how many nematodes your orchard has when the condition is very favorable, which is around late summer, and that sampling can tell you like how worse that can be. But for management purpose, we really recommend sampling before establishing any orchard or before the start of the season. And one of the reasons behind like having high number of nematode in the first sampling in each year compared to the second sampling was that the first sampling coincides with the highest crop root and shoot growth timing. So more root we have, the more food is available for the nematode, and they can reproduce the more.
Oh yeah, I should make one clarification. So this was an unfumigated block. no fumigation on this one, and we'll get into conversation about fumigation if you're interested. We have another study going in that's looking at fumigated versus non-fumigated.
So, is there any way you could include in your tests anion demand, nitrogen, sulfur, phosphorus, or
We have all that.
exchange, determine the exchange?
I just gave the highlight today, just for the sake of time, but we have pulled a lot of that information. That already exists. I just didn't present on it today. That'll be whenever I get to my defense, and everybody has to come and hear me on. Good job, Jeff. And I'll have all that then. So.
All right.
Okay,
Any more
to you.
questions?
Anybody else?
All right.
Thank you. All right. Let me see if I can get this thing to. There, it'll be a little higher.
All right. Thank you. All right. Well, I want to highlight two. Oh yeah, thank you. That we don't have today here Guido Schnabel, but he's a crucial part, and I mean from the inception of the ideas, especially on the side of the tree health. However, we'll have him later for the roundtable discussion through Zoom. Initially, he was going to present this set of data, but in the end, I'm presenting. Because here we include some of the bronzing and disease aspects as well. As Jeff was saying, we have an enormous amount of mulch coming after the tornado that got Oconee County. And around that time, we thought also it would be good to know if this mulch has any effect if we apply it on a mature orchard. In this case, of course, we're not incorporating the mulch in the soil. It's just a topical application. But do we see any effect if we just do a topical application? So you can see, I mean, I'm going to talk about this layout and these treatments in a little bit, but this is how it's going to look. No, like in this case, we're laying out the mulch right under the canopy of the mature orchard. Okay. And the idea behind was like, well, other than the nutrient and the cation exchange capacity and the soil chemistry, that mulch could definitely be a buffer for soil water and temperature. It can help slowly because it's not incorporated, but it can help or maintain or increase the amount of soil carbon. Eventually provide nutrients because this mulch degrades quite fast under our conditions, and we think increasing soil life and all these, we think that it can improve soil health, biological, chemical, and physical characteristics, cause less stress, and eventually improve tree health and productivity. So that's the idea behind. So in this part of a presentation, I'm going to talk about three components: nutrition, tree nutrient status, growth and yield, and then the marketable yield. And specifically what we have seen on bacterial spot and bronzing. So our hypotheses were that trees that were amended with amended soil will have higher availability of nutrients, that it would increase growth and yield, again, kind of like in the same line as Jeff was observing, and it would have less disease and disorders, even though that's just the hypothesis, but again, based on all that pine conversation that he was telling us. Methodology, we started this in 2020. We have three treatments. The first one is control, and I need to clarify, this is not clear as we have it in there. The control trees was bare soil, no mulch, and those followed the regular fertilization, commercial, standard fertilization that we have in the red guidelines. But then the mulch, the trees that receive mulch, topical application of mulch, that 75% of fertilizer is the replace. It replaced 75% of the synthetic fertilizer. Okay, we only apply 25% of the synthetic fertilizer. Again, sorry, that's not clear here. And then the same with the mulch and litter. We did not fertilize with synthetic fertilizer, mulch and litter treatment, because there was a lot of nitrogen. We calculated everything based on the nitrogen amounts that we were putting, and that mulch and litter, this is chicken poultry litter, had already a lot of nitrogen, comparable to this control, so we decided not to put any synthetic fertilizer. So again, this receives 25% of the fertilizer, this receives 0 synthetic fertilizer. It was applied similar to what Jeff showed with the same row mulcher. And in this case, what we have was, we have 3 rows of peach trees. We have 2 varieties here, June Prince and Scarlet Prince, 10 trees of each for each treatment. So if this is mulch, these 10 trees are bare soil, and these 10 trees are poultry litter and mulch. Okay, both things. Same for the 3 rows. We measure their trunk cross-sectional area, yield, many other measurements like photosynthesis, etc. When harvest time came, again, of course, yield, but then we also rated these fruit for bronzing. We had scale of, we first did incidence, like it has bronzing or not, and then how much, like severity. It was with a scale from 0 to 4, 0 having any spots, and 4 having up to 50% of the peach surface. Similarly, we did for bacterial spot. A 0 would be, this was from 0 to 5. 0 would be completely clean, and a 5 having more than 50% or 50% or more of the area having some bacterial spot. Now, this is an orchard where we did not have to inoculate or anything. There is always bacterial spot there. We also took soil samples. And so let me show very quickly some results on soil chemistry. We did not see, this is a topical application again, so we did not see a change on organic matter or cation exchange capacity over the first 3 years. And precisely because it's just topical. If you remove part of the mulch, you can see underneath the native soil. It takes time for that mulch to degrade and little by little change the soil chemistry. We expect that it will change it, but so far we have not seen that change. Okay? Similar with soil nutrients. I mean, this is kind of like a quick summary, but for phosphorus, potassium, magnesium, calcium, we are not seeing any change in the soil nutrients yet. However, when we look into the tree nutrient status, leaf nutrient analysis is always done in summer. In our case, we were taking leaf samples in spring, in summer, and in fall, kind of like to try to follow what's going on there. And so that's why we have here three points for each year. The PLM, the poultry litter and mulch, would be the white square. The mulch would be the circle, and the grower standard or the bare soil would be the triangle. And we can see how in spring, not in fall, not in summer, like if we collect the sample in July, like for a regular tissue analysis, we wouldn't see any difference. But in spring, the poultry litter and mulch was showing higher nitrogen in 2 of the years for June Prince, and in 1 of the years for Scarlet Prince. If we look at potassium, we have a similar picture for several of the years. The poultry litter and mulch showing higher concentration than control in spring. And then, that was phosphorus. For potassium, we see it sometimes both in all the seasons, in spring, in summer, and in fall. So even though those changes were not seen in the soil, we could see them in the leaves. Now, you can imagine what this would mean, like having higher nitrogen in the spring leaves and later not having them in summer. This is going to lead to increased vegetative growth because we have a lot more nitrogen in those leaves, right? So that's something that we saw when we measured tree growth. Here we are showing shoot length, not height, but shoot length. We measure about 20 shoots per tree, and trunk cross-sectional area. And even though there are no significant differences, we did see a big increase in the mulch plus poultry litter between these 2 years. Here I'm saying how there is the summer 2021 the mulch and poultry litter treatment did not significantly have longer shoots, but I can tell you that there were more shoots. Those trees with mulch and poultry litter had more vegetative growth, were more like they were bushier than the control. And that had an effect on delaying the ripening. Like when we went to harvest, like in our first peak, the poultry litter and mulch treatment have very little fruit in that first peak compared to the control or the mulch. However, when we got to the third peak of the control, that's when we have our main harvest for the poultry litter and mulch. So it delayed, being so bushy, it delayed harvest. Again, that was with zero fertilization, synthetic fertilization. Let's look now at the bronzing and bacterial spot. And it's a pity that now Ross just left. This was very interesting because in that blog we were rating this orchard for bronzing, and we consistently saw, especially when we have a mild incidence of bronzing. When we have a lot of bronzing, it was everywhere. But when we have not so much pressure, we could see how either the mulch mulch and poultry litter tend to show lower incidence of bronzing. This is for scarlet prints in 2021. When we look at scarlet prints in 2022, we saw the same trend. Mulch and poultry litter had less bronzing. Here we have some events, rain events. Again, bronzing went up. A lot of incidents here, so there were no differences. For the third peak, it went down a little bit, and there we saw again the differences. Poultry litter and mulch, they both have less incidence of bronzing compared to control. If we look at severity, we see the same trend. Mulch and chicken and poultry litter and mulch tend to have a lower incidence, severity of bronzing. When we had, again, in this case, in the third peak, high incidence, the numbers changed. But again, for the 2022, kind of like the same trend, unless it was really high, as I was saying before. That's when the numbers don't make sense. But when there was a mild severity or a mild pressure, mulch and chicken manure tend to decrease bronzing. And then this was very interesting, the bacterial spot incidence. This is something that we were not expecting, but 1 year after applications of mulch in 2021, the 2021 is these purple bars, we were seeing how in two of the peaks, both treatments had significantly lower bacterial spot than the control treatments. The second year or the third year in 2022, the pressure of bacterial spot was very, very little in this case, so that didn't stay. If we look at the severity, we saw the same thing. Mulch plus poultry litter in 2021 was lower, bacterial spot was lower in those two treatments. So as a conclusions, organic matter amendments maintain that nutrient status of the trees despite the reduction in synthetic fertilization. It can increase vegetative growth, and with the poultry litter we have to be careful. And we have seen reductions in bronzing under low pressure and bacterial spot with mulch and mulch plus poultry litter. I want to highlight that all this work and what Jeff is doing has been done with zero funding. We don't have any grant yet, and we hope that these data help us prepare a portfolio and some preliminary results to apply to some big grants, and hopefully including the industry as well. But so far it has been thanks to a lot of manpower and women power and people from Master Farm. So a lot of people from both labs have been involved. We recently, Haha Wang, our bacteriologist, has got a grant from Southern SER, and this part of bacterial spot is going to be studied more in depth thanks to this grant, but this is something that is starting this fall. And I'm going to change now to another study on the use of food waste compost, but maybe if there is any specific question on this study on mulch, we can address it now, and then later we can go to more general questions. Yes.
I have one, just to clarify the parameters that you put your trial. Were each of the treatments, did they receive an equal amount of nutrients
Yes.
based on the source?
Yes. So my graduate student,
The mulch, the amount of mulch or the amount of litter that was applied was based on the nitrogen content in that, so equal amounts, equal amounts of nitrogen was available, whether it was in the control, or whether it was in the mulch, or whether it was in the mulch plus the litter.
so before applying the mulch, and the poultry litter, we took samples and analyzed them and see how much nitrogen was there. And this is an estimation, but we did our best bet on how much of that nitrogen would be available to try to, get our best approach on getting balanced. Like the amount that we're putting with synthetic fertilizer being the same as the amount that we're putting with the mulch and poultry litter. And so that's how we balance the having no synthetic fertilization in there. You have some?
The inverse of that was on the study I was working on, is we pretended like we weren't putting anything. I mean, we still maintain commercial standard applications of NPK in addition to the organic applications. Very quickly, we've learned that we're just way overdoing it, and so this last, we had to do a half rate this last fall application, or late summer application.
Well, the thing with litter is it's a great source, but it's unpredictable over time.
That's right, and that's what I was trying to say, it's just tricky.
It's very easy to say 40% is available, the remainder is available as it's broken down.
Right.
In organic. Just one note, the bronzing, I don't know, you said it was reduced in the mulch and the mulch plus the litter. Phosphorus in the form or an organic form in it is typically more available to a plant than has applied from a commercial source. So that greater availability of phosphorus might very well, because typically we don't put out phosphorus
Right.
in a
Just-
commercial
Well,
orchard.
it was
What
pretty
we
shocking, when, it was really almost an accidental find, but we weren't looking in particular for it, or think, we were looking in particular, but we didn't think we were gonna find very much, because these are just 10 trees in a row. How can these 10 trees be different than the 10 trees in the other part of the same row, when it's all, the bacteria spread evenly seemingly through the orchard? But it turned out there wasn't significant.
With bacterial spot, there is always this thought of sand blasting, but again, in that type of orchard, when you have the control bare ground that could have some sand, that could next to, that was, our hypothesis now, it's more related to what's the effect. Is that, for example, an effect of addition of calcium on those surfaces that is making the fungus more difficult, the bacteria more difficult to penetrate, things like that. No, not related to the impact of sand in that treatment. Yes.
For both of you, did you observe any kind of weed or herbicide problems when you put the mulch down?
Yes.
And
It-
then the next question is, what was your herbicide system?
Well, we maintained a conventional herbicide program. So,
Using what?
well, we used Roundup, we used Chateau, we used Gramoxone, all the standard stuff. We hoped that the weed pressure would go down, but what we found
Over
is the
time.
weed pressure went up because our pre-emergence didn't work as well, because they weren't contacting the soil. That's the running hypothesis. So we actually saw increased weed pressure on the mulch rows. It was fairly easy to control. There was no stubborn weeds that were there. It just, it was not what we had anticipated.
Okay. Okay, so can move on to the next presentation, and then again we can discuss more general questions at the end of this. So with this one, we did something similar to what Jeff did in a newly established orchard, but we use food waste compost. Okay, we actually, it was a very nice thing because we got food waste compost from the dining halls at Clemson. So what students don't eat end up at Master Farm. This has been the Brian Lawrence was my PhD student. He just graduated. So most of this work was, or all of this work was done by him with the support of Guido and myself. And the goal here is to assess how these annual applications of food waste compost can change, same thing as Jeff, soil properties, peach tree nutrient water status, tree performance, and tree health throughout the life of an orchard. Here we're going to focus on tree nutrient status and tree performance. So far we have not seen any issues of tree health. This was done again at Master Farm. By the way, you can see here the piles of mulch that we had received from Oconee. This was done at Master Farm, and we have two locations. We did it in this part of a hill. This was a replant orchard. There have been peaches there for 30 years, something like that. And they were pulled out, 2 years ago? 2 years before this started. And so we planted a new orchard there. But we also wanted to look into what's the effect if we apply this food waste compost on a virgin soil. And then, we were able to do it down the hill, a little bit down the hill, in this area where we have never had peaches. And we had, again, similar to what Jeff did, we have two rates, a control that is no compost, but then we have the compost one, which was 10 tons per acre of compost the first year at planting, before planting, and then 5 tons each year after. And then the second treatment, compost 2 times, or 2 rate, two rates, would be double that, 20 tons of compost the first year per acre, and then 10 tons per acre each year after. The layout was a little bit different because of, again, the characteristics of the location, the slope, etc. But we have, it was randomized this way for the virgin location, and the replant location was entire rows per treatment. The very first year we did not have a row mulcher, that the Mill Creek that Jeff showed, and my student is a perfectionist and he wanted to get it right, and so it was done the hard way.
Are those rates based on just dump weight, or is that dry matter? Is that dry weight?
That is the net weight. Dry weight? Was it dry weight? Okay. So as I was saying, it was first added to the soil, and then again bucket by bucket, and then later mixing, mixing, and the beds were made and all that. That was before your experiment, right? 1 year before, I think, before your experiment started. Trees here are after the first 1 year old. They kept growing. You can see how those 20 tons, how little it looks. It looks like just a sprinkle. After the second year, they were, we tried to follow all the practices, like standard practices. They were root collar excavated. Then we got the row mulcher, and since then we apply the compost that way. It's again topical applications. It's not mixing after the second year, but it helps a lot. It makes it a lot easier. This is after 3 years, and by the way, the fertilization here, again doing those numbers of how much are we applying and all that. In our compost one, we reduced 50% our spring fertilization, and we did not do any post-harvest fertilization. in our compost 2, there was a 62% reduction in fertilization and no post-harvest fertilization. We measure all these parameters we mentioned before, trunk growth, well, actually I have pictures here, collected yield. We have sensors to measure the soil moisture, canopy volume, trunk cross-sectional area, photosynthesis, everything. Again, I'm just going to highlight a few. For tree growth, a few results for tree growth, we have again trunk cross-sectional area and canopy volume. The first and second year we didn't see any difference. Starting in 2021, we saw differences in the virgin soil only. We did not see an effect on the replant soil. And then in 2022, these differences are maintained. If we look into, what's next? Okay. The tree, is this the same? Wait a second. Yeah. And tree nutrient status. Here I'm just showing one measurement, the one in summer. But as you can see, for the, well, first of all nutrients were within the optimal levels, even though some of the treatments receive a lot less fertilization. And then we can see how the compost treatments for the replant location had higher leaf nitrogen, phosphorus, and potassium. Okay, at least for some of the years. It's not always consistent, but there is that trend that they show higher leaf nitrogen, phosphorus, and or potassium. Let's look into the yield. We have yield and some fruit quality parameters, again, per location and virgin replant and treatment. And we can see how we have not seen differences in pretty much anything. Only one of the years, 2021, we saw some differences in firmness, like there was some delay in ripening for this 2X treatment. Even though we do not have differences in yield, we kind of like numerically, you can see how these trees are, if you compare the 2 times, I mean, it's actually, like you can see how controls, it's lower than 1X, and 1X is lower than 2X. We can see it in both. I mean, if we do the accumulated yield, probably we will start seeing differences, or maybe now in the coming years. But these were not statistically different. Even in the replant, the 2X tend to be higher than the control, again, numerically, in this case similar, but again, we expect that over the years, this will make a difference in accumulated yield. So quickly, conclusions, the 2X rate increased tree growth. Both the 1 and 2X rate resulted in similar leaf nutrient concentration, even though there was reductions in synthetic fertilization. And again, we need to continue this project, even though the student graduated. This project is going to continue throughout the lifetime of the orchard to see both tree health and long-term sustainability. And with that, I think that's all the content that we have. And now we can get, Guido should be on a Zoom, and so we can get him on the panel as well.
If he's awake,
Guido, are you there? Hello, Guido, are you awake? Oh, yeah. Guido, are you there? Maybe we need to call him. Okay, here he is. Yes, he's awake.
Hey there, can you hear me?
Yes, loud and clear.
Very good. Well, thank you so much for these excellent presentations and for covering me. So thank you so much. I wish I could be there, but COVID hit the entire family, and I was last, and I'm just now recovered. So hopefully this is all going to go away soon. Anyway, I wanted to also just add a few comments with regard to soil health. And the idea really came about due to desperation, because there are diseases that we can control, that we can spray for quite nicely. Those include brown rot, scab, and these things. But then there are diseases that cannot be controlled with any integrated pest management program, especially if the weather conditions are conducive. And that would be, for example, bacterial spot and bacterial canker. All these diseases that are caused by bacteria are just very tough to control. And bacterial canker specifically is something we have absolutely nothing that we can spray for. What we can do, though, is make the tree as strong as we can get it. And so the idea was to improve the soil with the goal. Hold on. I'm talking to myself here. Where was I? So, bacterial canker. Yeah, so it's very hard to control, and the idea would be to really improve tree health by improving soil health. And there's several examples out there that Jeff already mentioned, where just growers that grow peaches or cherries, they don't have a whole lot of bacterial canker problems. You know, bacterial canker is caused by Pseudomonas. And you go to pretty much any production area with good soils, and Pseudomonas is just not that big of a problem. I mean, they have it here and there, but not nearly as big as it is in the southeastern United States. So that's how the whole thing came about, and I'm really happy to see those preliminary results, especially the ones that Churamani has shown. Because, as we all know, bacterial canker needs a weak tree, and nematodes is a predisposing factor of bacterial canker. If we can control the nematodes, then we should have much less of a bacterial canker problem. So I'm excited about this whole project because of also to me the side benefits of potentially less bronzing, potentially less bacterial spot, and just maybe a orchard that is more sustainable, lives longer, is tougher now that we're also facing climate change issues. That would be, I think, the long-term goal. So with that, I'm just gonna be part of this discussion, I hope.
I also want to bring up. I also want to bring up the big elephant in the room, which probably everybody's thinking, like, how much does this cost, right? Which we don't know yet how economically feasible this is. But I also want to talk about, okay, well, not only that so far everything that we're getting, it's either the same or better than we have, and the possible reductions that we could have with fumigation. But the point that I want to bring up is one from the outside of the United States. In Europe, they started decades ago with municipalities collecting food waste. This past year, even in the news of my hometown, they were saying that there was that stink, that smell, where is this coming from in the city? And that was because all the orchards around the city are putting compost. It's really, really cheap. And I think it's something like €7 a ton of compost. And if, like, trying to translate this in here, if we think back of 10 years ago, how many companies making money out of, selling compost, or how many municipalities here in our region were making compost out of food waste? They were probably known to, zero, I think. However, now we have more. And maybe it's not economically feasible yet, but I am pretty sure, seeing the trend in other countries, we need to start this research early, because we need a long-term research to collect enough data. And I don't know how, if this is going to be something that we can start implementing now, probably not. But if we try to think of what's going to be the situation in 5 years or in 10 years, again, that elephant probably is not going to be as big as we have it right now. But anyways.
Well, I need to ask, your litter that you're using and your food waste that you're using, you know, the component in your mixture, is it certified pathogen-free compost?
No.
How are you going to address food safety?
Right.
Applying litter?
Yeah, so the question was, how do you address food safety as it relates to applying litter, poultry litter to existing orchards? The timing of it is tricky. So basically, you got to be, if you're putting on litter, is it 100 days?
Before harvest.
Yeah, so basically you've got to do it, and we followed the rules. We just had to put it on really early before the fruit was ready to harvest. 100 days, I guess.
For a lot of your elevated certification bodies, like if Walmart, Costco, you're not supposed to use any
Yeah.
organic soil amendments, and if you do, they have to be treated.
Yeah, so we haven't dealt with that. That would be something in coming, you know.
Is that a gap? Because the gap standard is 100 days.
Yeah, this is elevated
It's
above
individual.
that.
Okay.
This is all retailer driven.
So the food waste compost from the university, they did have a time temperature rating on it. I don't know that it was rated for pathogens, but there was not a kill step built into that. So it's a good question. Thank you, Greg. Questions?
Just to comment on the one study where you equalized it by nitrogen, if phosphorus is, because that is the huge difference between your control, because control you're mainly just putting nitrogen, right? Some potassium, if you're following normal standards, would be easily to equalize instead on phosphorus instead of equalizing it to nitrogen.
Yeah, we did it on nitrogen. And you had to pick one. But
in response to the earlier.
yeah, it could be done through phosphorus.
If that was the factor that was, because that is a big difference between the two. And soluble phosphorus, you could still equate it with a chemical phosphorus, but you still wouldn't get the soluble phosphorus that he was speaking of. But at least it would be equal on a pure phosphorus level.
Yeah.
Just an idea.
Yeah.
Most nutrient management plans, they only get into balancing an application rate based on phosphorus if you're getting close to exceeding that threshold. And one point I said, and in the studies we did, organic phosphorus, we know if we apply a surface supply, P in a commercial fertilizer, it stays right there. We're not going to address anything. Organic form does seem to move down quicker into the root zone.
Yeah.
Therefore, it's more available to the
So again, one of the big takeaways from the study is that balancing the organic nutrients is complicated versus it's a lot more complicated than inorganic fertilizer.
Other thoughts or ideas or suggestions or questions?
Probability of being able to find as much, which I know you're not looking at the direct application, but on especially the larger farms, being able to find that much mulch, especially like the 10 tons per acre. I mean, even on a 10-acre block, it's huge. Not to mention the annual, locating that much could be a concern. But I mean, it's good that you're doing what you're doing to establish to begin with. So I get that, but I know from a grower standpoint, applying some of this is going to be difficult if it does continue to show out. We're not at the point of recommending this, right?
No. I mean, based on that gold standard, that the results that we got, for example, from his study, we're starting a new study. I mean, planting this year at Maser Farm, where we will have only mulch incorporated. I mean, composite mulch incorporated, and not topical application. Or only topical application, I mean, from establishment, and not incorporated. And other treatments would be both, but only once, the first year, or every other year. And non-fumigated and fumigated. and we'll see what, now it's when we start getting deeper into the,
More of the system trial, and like how do we specialize this thing?
because we may get the same results if we just do the incorporation 1 year and that's it. And if so, I mean, that would be great.
That's going to be the important part.
That's it.
Lower amounts.
But we don't know. I mean, we started high and it worked. So let's,
Might lose it, yeah.
what else?
Did you say the mulch delayed bloom, and if so, how much?
Yeah, so one of the things that we're rating for in the one I presented is actually we're rating for bloom, and it did delay it by several days. But I think that's more a result of it had more nitrogen, and that tends to push bloom back. The other thing that it caused is then we ended up pruning off a lot of wood. We grew a lot more wood on the heavy nitrogen trees than we wanted to. So.
How did those trees look the fall before they were in the dorm?
Sorry, which trees?
The trees with the heavy organic mulch with the litter, how did they look the year before, or was this the year applied effect? The delayed bloom.
The delayed bloom would be from the year before effect.
Delayed, prolonged.
Yep.
delay of dormancy.
Yep, because they pushed further into the winter before they defoliated, and then they came out later. So that was I think that was a straight up nitrogen effect. So part of that now is I didn't want to have to do the math. Basically, perhaps I was just being lazy or trying to think like a beach grower. Just the fertilizer's cheap. I'm not cutting back on that. Just keep putting it down. Well, it turns out you do have to consider. You're putting out nutrients in the mulch in the compost, so you have to compensate for it, or you overdo it. But that's my middle name, so overdoing it was fine. So.
Over time, you'll see an increase in the nitrate nitrogen.
Yeah.
I'm assuming that's a Cecil soil,
Yes, it's a Cecil soil.
8 inches clay layer. You're going to have an increase in nitrate nitrogen building up there. That is plant available over time. You'll need to balance that
Right.
as well.
Yeah. So the balancing the nitrogen's complicated, and that's part of what we're going to be getting into this next year, because it's now obvious after year 3 we can't just keep doing it the way we were, because it'll be way out of whack quite soon. Because basically we'll be growing tons of wood, and all our fruit will be right at the top of the tree, and will be nothing, no bud wood, no fruit wood down in the bowl of the tree at all, because it'll have all outgrown and then shaded out, and all the buds die in the bowl if we don't cut back on the nitrogen. Yeah, with fertilizer prices isn't such a bad thing right now. So,
Guido, is there anything else you want to add?
Maybe just to follow up to Andy's very good point. The goal here is to cover those tree rows with some sort of organic material, some sort of a mulch, something, or doesn't have to be compost, but something. And so we were trying to figure out what that something could be. Is it, municipal mulch? Is it does it come from forestry, sawdust, or leaf litter, or I don't know if there are any growers participating in this discussion, but I would ask for maybe some ideas. What kind of mulch we could actually apply in a consistent manner year after year that would be somehow available and not too expensive.
I mean, what we're doing is we've got sawmills very close, and so I've been getting, the salt chips and stuff out of the sawmills. It's not that difficult.
yeah, so sawmill chips, sawdust out of timber industry.
But I do want to make a comment. I think that what you guys are doing here is good. It's logical, right? Like the immune system of the tree is its roots in the zone we can provide better health there, the tree's gonna be better off, it's gonna be more, it's gonna be stronger. So I mean, this is something that we've been kicking around for years and years and years. You know, just general soil health could combat a lot of these issues we spent 2 days talking about. We look at our soil chemistry, we don't pay very much attention to our soil health at all.
Yep. So yeah, Ross, thanks for that. And that's really what the goal of this whole thing is let the tree look after itself better.
We haven't talked about the physical part of a soil either, even though we have some measurements. And this soil crust that we often see, that it doesn't let water penetrate, and in the end causes more erosion. When at the moment when you start adding some organic matter in there, like with the soil moisture sensors that we have, we can see that buffer capacity of avoiding less water, like water loss, and at the same time when it drains, how it's kind of like more like of a sponge, how it works, like it retains and holds more water. No? So the long term, there are many long term effects that I think will keep coming, but absolutely, I think it's a multi-component thing.
I wanted to ask Guido his concerns as far as soil microorganisms, particularly armillaria and other soil organisms like Fusarium, Phytophthora.
Do you want to ask him through the microphone?
Can you hear, Guido?
Can you hear me?
Yeah, I heard the question. So the strategy that we're applying here is to add fully composted material to the soil before planting. So that shouldn't have any pathogens because it's fully composted. So all that's in there is the microbials that have basically consumed everything else and created a balance of microbiome. So there shouldn't be really any pathogens in there. So then you apply this, and then you come back every year with some sort of a mulch, but that mulch is not being integrated in the soil. It's just being put on top of the existing surface. And if there is a root piece with armillaria located in that topical mulch, I wouldn't be concerned about it. The fungus is not going to go from there to the roots or to the crown. That's not how it works.
Guido, the concern with existing soil in replanted soils where armillaria, you're not completely removing the existing soil, you're incorporating the compost. In the plum situation, in the resistance with the new root stocks and whatnot, they're much slower growing. So with increasing growth rate, we typically get increases in armillaria. So my concern, but I agree, you are incorporating a lot of beneficial microbes, so you are lessening in a way, but you do still have that existing armillaria in that soil. If there's been peach trees, well, just about any soil I know of.
So
I would not expect there to be any effect on the endemic armillaria. Armillaria is a pathogen that doesn't really need a stress tree. So our fungus that causes armillaria root rot, the Armillaria tubescens, is really, if you have it in the soil, it's gonna attack your tree no matter how high that organic percentage is in the soil. It is gonna kill that tree. Armillaria needs to be controlled with means other than soil health. It needs to be controlled culturally, delayed with the root collar excavation, or long-term with a rootstock that would be tolerant or even resistant to armillaria. So this project is not focused on any armillaria control.
That's what I would think. Thank you.
thank you, Guido. think we better wrap up. Any last questions? And other than that, we'll wrap it up.
Finish up, take a quick break here, everybody go outside and warm up.
Thank you all for your time. I appreciate it.